Good morning all of you. I completed the second element of highway cross section, that is pavement surface, in the last session. Okay. Now I proceeding with the next element, that is camber. Camber. First you may get the definition of camber. Okay. The camber, it is the transverse slope provided to the road surface. Okay. The transverse slope provided to the road surface is called camber. The transverse slope provided to the road surface, okay, is called as camber. Okay, and it is also called as cross slope, because the slope which is providing the transverse direction means across the pavement surface. Transverse slope means the slope provided across the pavement surface, that is called camber, and it is also called cross slope. The camber is also called cross slope. Then what are the objectives of providing camber? We move on to the objectives of providing camber. Objectives of providing camber. Okay, there are about 3 objectives. The first one, it is to prevent the entry of surface water into the subgrade soil through the pavement. Okay, this is the first objective of providing the camber, to prevent the entry of surface water into the subgrade soil through the pavement. Okay, the stability, surface condition and life of the pavement get adversely affected if the waters enters in the subgrade soil and the soil gets soaked. What will happen means, if the water enters in the subgrade soil, then the soil gets soaked. Is it clear? Means when the water enters in the subgrade soil, then the soil gets soaked. When the soil gets soaked means the surface condition, the stability and also the life of the pavement get adversely affected. Okay, that's why your camber is providing to prevent the entry of surface water into the subgrade soil through the pavement. Okay. Second objective, to prevent the entry of water into the bituminous pavement layers. Okay, to prevent the entry of water into the bituminous pavement layers. What will happen if the water enters into the bituminous pavement layers? As the continued contact with water, the bitumen may stripe off from the aggregates, okay, and results in deterioration of the pavement layers. Okay, as the continued contact with water, the bitumen will be striped off from the aggregates and results in deterioration of the pavement. Deterioration means becomes worse. The pavement layer becomes worse. Okay, that's why the camber is provided to prevent the entry of water into the bituminous pavement layers. Okay, and the third objective it is to remove rainwater from the road surface as quickly as possible to allow the pavement to get dry soon after the rain. Okay, the third objective of providing camber is to remove rainwater from the road surface as quickly as possible and to allow the pavement to get dry soon after the rain, because we know that the wet conditions of the surface of the pavement provides discomfort for the road users, or it is unsafe for the road users which traveling at the high speed, for the vehicles which moves at the high speed, and also the wet surfaces, okay, reduces the skid resistance. Thereby there may chance of slipping of vehicles. Okay, that's why if you provide the camber, it may remove the rainwater from the road surface as quickly as possible and allow the pavement to get dry soon after the rain. Okay, then the surface of the pavement, the surface of the road becomes dry, then the adequate skid resistance we can achieve. There may no chance of slipping of vehicles. Is it clear? Okay, these are the three objectives of providing camber. Then you may know that the camber may be provided both in straight roads as well as in horizontal curves. Okay, what they are going to do is, in the straight road they are going to provide the camber by raising the center point of the road with respect to edges and forming a crown. Like if this is a road surface, okay, they are going to raise the center point of the road with respect to edges and they are forming a crown. This is the crown. Okay, they are going to raise the center point of the road with respect to edges, forming a crown in straight roads. But in horizontal curves, what they are going to do is, instead of raising the center point of the road, they are going to raise the outer edge of the pavement with respect to inner edge to drain off surface water. Instead of raising the center point, they are going to raise the outer edge of the pavement with respect to inner edge. This is at the horizontal curves. Okay, this is outer edge, this is inner edge. Okay, they are going to raise the outer edge. With respect to inner edge at horizontal curve to drain off the surface water. Is it clear? Means in straight roads they are going to raise the center of the road with respect to edges of the pavement, forming a crown at the center. This is the crown, forming a crown at the center. At horizontal curves, instead of raising the center of the road, they are going to raise the outer edge of the pavement with respect to inner edge to drain off the surface water. Is it clear? Then the camber will be expressed as the slope of the line joining the crown with respect to edge of the carriageway. Okay, the camber will be expressed as the slope of the line. This is the slope of the line. Joining the crown. This is the crown, no? The slope of the line joining the crown with respect to edge of carriageway. This is the camber. Is it clear? Okay. Next, the camber will be expressed by in terms of 1 in n. The camber will be expressed in terms of 1 in n. Means for n horizontal distance, 1 meter vertical. For n meter horizontal distance, 1 meter vertical. That will be expressed in terms of 1 in n. That is, camber will be expressed in terms of 1 in n. Is it clear? Then the amount of camber to be provided mainly depends on two factors. The amount of camber to be provided mainly depends on two factors. Those are, number one, it is amount of rainfall. Amount of rainfall. Second one, it is type of road surface. Type of road surface. Okay. The amount of camber to be provided mainly depends on these two factors. Amount of rainfall, type of road surface. Is it clear? Next, I will move on to the types of camber or shapes of camber. Before gone to the types of camber and shapes of camber, you should know that excessive camber should not be provided unnecessarily. Excessive camber should not be provided unnecessarily, because the excessive camber, okay, provides discomfort for the road users, particularly the road users traverse on the crown while overtaking operations. Okay, excessive camber provides discomfort for the road users which the vehicles traverse on the crown, particularly during overtaking operations. And also, the heavy loaded vehicles may topple over very easily. Heavy loaded vehicles may topple over very easily if you provide the excessive camber. Then the roads get weared out, particularly at the edges, quickly than at the center. Means the edges of the pavement get wear out quickly than the center point, because what will happen, the vehicles moving on one side of the center line may remain tilt towards the edges of the pavement. May remain tilt towards the edges of the pavement. Means if you provide the excessive camber, the vehicle move like this. The vehicle move like this, means it is one side of the center line, at one edge of the center line. That's why the edges of the pavement, okay, wear out faster than the center of the road. Okay, these are the three disadvantages of providing excessive camber. Providing excessive camber. What is the first one? Okay, it may causes discomfort for the road users, okay, which the vehicles moves on a crown for vehicle operations, particularly in the overtaking operations. Second one is heavy loaded vehicles may topple over easily. Third one, the edges of the pavements wear out faster than the center. Faster than the center. Is it clear? Okay, that's why while providing the camber, we have to provide the adequate one. You have to provide the adequate one. Don't provide the excessive camber. Is it clear? Next is types of camber or shapes of camber, we can say. Types of camber or shapes of camber. One and the same. Basically, there are about three types of camber. They are, number one, it is parabolic camber. Second one, it is straight camber. Third one, it is composite camber. Composite camber. Okay, these are the three types of camber: parabolic camber, straight camber, composite camber. Okay, I'll go one by one. Parabolic camber. So W is the width of the pavement and Y is the ordinate at any distance x. Y is the ordinate at any distance x, and the slope of the line joining the crown with respect to edge of carriageway, that is the camber. No, this is the slope of the line joining the crown with respect to edge of carriageway, that is 1 in n. That is 1 in n. It is the camber. Is it clear? Then the ordinate at any distance x, y, for this parabolic camber, it is y is equal to 2x square nw. 2x square nw, where x is the distance at which the ordinate you are going to measure, and n is the camber, and w is the width of pavement. W is the width of pavement. Okay, this is the parabolic camber. Next, straight camber. Straight camber. So this is the width of the pavement W, and 1 in n. 1 in n is the amount of camber. Then this is the crown. Okay. If you want the height of the crown, it is W by 2n. W by 2n. This is the height of the crown from the road surface. Crown is this one. This is the crown. Okay. If you raise the center point of the road with respect to edges, that will form a crown at the center. Okay. If they are asking to find out the height of the crown, then it is W by 2n. Okay. Height of the crown. For this, height of the crown is equal to W by 2n. This is for straight camber. This is for straight camber. Okay. The next is composite camber. Next is composite camber. Composite camber means it is the combination of parabolic camber and straight camber. The combination of parabolic camber and straight camber called composite camber. See here. See here, this is straight camber, then followed by parabolic camber, then followed by again straight camber, straight. Okay, this is the composite camber. This is a W. Okay, it is a combination of straight camber and parabolic camber. Okay, straight followed by parabolic followed by straight. This is the composite camber. Okay, this is regarding types of camber or shapes of camber. Okay, next I'll move on to the IRC recommended values for camber. IRC recommended values for camber. IRC Indian Roads Congress recommended values of camber, IRC recommended values of camber. Okay, first column it is types of road surface, second one it is range of camber in areas of rainfall range, and this is from heavy to light, Okay, the first one it is in the road surface, it is cement concrete or high bituminous surface, cement concrete and we can say not or cement concrete and high bituminous surface. For that the range of camber it is 1 in 50 to 1 in 60, that is 2%. 2% to 1 in 50 means it is 2% to 1 in 60, that is 1.7%. This is from heavy to light, means for cement concrete and bituminous surface, if in the respective locality if the rainfall is heavy, then you have to take 1 in 50. If the rainfall is light, you have to take 1 in 60. Okay, if they are not mentioning anything about the heavy rainfall or light rainfall, we have to take the average of that. 1 in 50 to 1 in 60, then the average it becomes 1 in 55. 1 in 55 is the amount of camber for a particular stretch of road. Okay, if they are mentioned in the particular locality is heavy rainfall, then you have to take 1 in 50. If they are mentioned light rainfall, we have to take 1 in 60. Okay, for cement concrete and high bituminous surface. For second one it is thin bituminous surface. For this it is 1 in 40, that is 2.5% to 1 in 50, that is 2%. Okay, for thin bituminous surface in the particular locality, if the heavy rainfall is given, you have to take 1 in 40 as the amount of camber, or if the light rainfall is given, then you have to take 1 in 50. Is it clear? And if you may not mentioning anything about the amount of rainfall, then you have to take the average of that. 1 in 40 to 1 in 50, then you may get 1 in 45. Third one it is water-bound macadam macadam, waterborne macadam, and gravel pavement, for waterborne macadam and for gravel pavement, this is from 1 in 33, that is 3%, to 1 in 40, that is 2.5%. Okay, for waterborne macadam roads and for gravel pavement, if the rainfall is heavy in the respective locality, we have to take 1 in 33. If the rainfall is light in the respective locality, you have to take 1 in 40. Is it clear? And if they are not mentioning anything about the amount of rainfall, heavy or light, then you have to take the average, that is 1 in 33 to 1 in 40. Is it clear? And fourth one, it is earthen roads. Fourth one, it is earthen roads. Earthen roads. For earthen roads, it is 1 in 25, that is 4%, to 1 in 33, that is 3%. Okay, for earthen roads, 1 in 25 to 1 in 33, that is heavy to light. No, means if the earthen roads is on locality which is having heavy rain, then it is 1 in 25. The earthen roads which is on the locality which is having the light rainfall, then the amount of camber is 1 in 33. Okay, this is regarding the IRC recommended values of camber. And you may see that no, the amount of camber to be provided will be depends on two factors, that is type of road surface and amount of rainfall. You may see here. Okay, the amount of camber to be provided mainly depends on two factors have explained earlier. Those are types of road surface and amount of camber. Based on the type of road surface and amount of rainfall, your amount of camber will be depend. Is it clear? Okay, this is regarding the camber. Okay.